Hi, this is Ed Alte. I'm just putting together a quick little demonstration to basically show what happens when we simulate a scenario that's been discussed on one of the RCU forums recently. That scenario has to do with what would happen if you're using an IBEC. In this case, it's a Tech-Aero Designs IBEC, Ultra IBEC, to power an ignition module. And what would happen if that ignition module were to develop a fault and inadvertently short circuit to where it was inoperative but drawing perhaps a lot of current. It's been speculated or guessed at that the airplane, you would immediately lose control of the airplane because the CDI module would draw so much current through the IBEC tapped into the receiver bus that you would almost immediately lose control of the plane. Now, I'm going to demonstrate that that's not really the case. If we accept the idea that losing power immediately in the engine when the CDI shorts out means you're going to be headed straight for the runway, very unlikely you'd be airborne even a minute, but we're going to go a minute or two at least, and basically show you what happens. So I've got a Spectrum DX8, I got an old Spectrum AR7000 receiver. Plugged into the throttle channel is the Ultra IBEC. We'll be simulating the short circuit in the CDI with this extension, which is just soldered at the end together so that we can do a short circuit. And we got a watch, which hopefully be able to see the time. Once I power it up, there'll be a voltage indication on the receiver bus. We're going straight from, this is where the battery will plug in, through this Radio Shack ammeter, or a digital voltmeter I should say. And even though it's Radio Shack, it's still a pretty decent meter. We're going to be going into the 10 amp line to be able to measure current. So the battery basically puts the this connection puts the ammeter in series with the battery, which then plugs into the receiver bus. Okay, and once we connect the battery to it, you'll see at first perhaps about 100 mils flowing, since we got a couple of servos, one on the rudder channel, one on the elevator. Got a little Spectrum data monitor, which maybe we'll take a look at. It's a pretty tiny display though. And we're going to run some servos, turn the IBEC on with the throttle channel once we get things started. And then we're going to introduce the short and we'll take a look at some readings and see what happens, all the while operating the radio successfully. This is only a 730 milliamp hour Thunder Power 2-cell LiPo. It's going to be going at full voltage to the receiver bus. It's an old battery. It's only 730 mils rated. I've had it at least 6 years. It's got hundreds of flights on it. I just use it around the bench these days, so it's tired. And if this little battery, which is kind of a low rating to start with, can run this thing for a minute or two, you really got nothing to worry about. So we're going to take it off charge. As you can see, it's in constant voltage mode. There's only a little bit left to go. It's I'm putting about 300 mils through right now, so it's pretty close to full charge, but not all the way there. Okay, so we're taking it off. Get the charger out of the picture, and we'll start the demo. Again, at first with no short. Okay, so we've got the elevator working, got the rudder working, and we got the IBEC working. Okay, IBEC is controllable through the throttle channel just like normal. Well, actually, that's how I test things. Normally it would be on a switch, but I'm showing it on the throttle channel. Okay. Alright, so everything's good. You can see that we get a little bit more current jumping around when we start moving servos around, but the idle state is about 100 mils. Now the current's going to spike up when I put the short circuit onto it, and it'll probably get to over 3 amps for a few seconds, and it'll pretty quickly come down to under 3 amps, because this regulator chip on the IBEC basically has a thermal protection circuit in it, and it's going to get pretty hot very quickly at those kind of currents, and it's going to start getting into a current limiting mode automatically. Okay, and you'll very quickly see a demonstration of how that works. So we got a working radio, and we're going to introduce the short, and you can quickly see about 5 amps. Things have slowed down, but they're still working. And look at that, it just jumped way down in current because the thermal limiting just kicked in on the IBEX chip. Servo speeded up a little bit, without anything running. You can see it's about 1.5 amps, moving around as it goes in and out of thermal shutdown. But those servos, they keep working. And this is an older technology spectrum receiver. It hasn't dropped out at all. We're still running up around 7 volts under this extreme load with a very old battery. And we've been doing this at least a half a minute. We're going to go a while. Let's just have some fun and watch what happens. You can see the current that's drawing is less and less because this is getting hotter and hotter. It's doing more and more current limiting. It still is working though, because as I remove the short, there it is. Still working. Low throttle to turn it off with my setup. High throttle to bring it back up. There's the short again. Still pretty hot. So it's current limiting down to about 1 amp. Okay, you can see with off, voltage is a little higher. On, voltage is a little lower. Okay. So this is a demonstration that hopefully would kind of allay any fears about a catastrophe that would happen if the CDI module were to short. It's not going to mean an instant crash. It's going to mean a really warm IBEC that basically kind of, like I said, will just sort of get into a thermal overload mode. Still trying to run what's attached to it, but it's going to go way down in current. So by now you would certainly have had a chance to glide to a safe landing, okay, and basically get a round of applause from everybody in the pit area. So one more time, this IBEC is pretty warm. It's down to about 0.79 amps. We still have a good 7 volts out there, even from a tired 730 milliamp battery. And everything's good. So this is probably getting a little tedious. We've gone way over our 2 minutes. Okay, we're going to pull this out. Watch the current go back down to about 100 mils. Servo speed up a little. Voltage went up a little bit because we got rid of that load. And voila. Thanks everybody.